Y'all, this is the end. This is the last one. You got this. Let's do this. Also, this is 0 things that are new. This is just doing 2 things to the same shape, which we already did in class. Actually today, but last time. So this is compound transformations, or a composition of isometries, or composition of transformations. These are doing more than one thing, 2, 3, or 4, or 5 to the same shape. So I might take a shape and I might rotate it and then I might flip it over. Or I might take a shape and I might translate it and then I might dilate it. I might take a shape and I might translate it, flip it, rotate it, dilate it. Who knows? That might be your bonus. Let's see if I can figure out something cool like that. So I'm just going to do 2 examples so you see them, see the correct annotation of the shapes, and I'm going to do 2 colors. So, if you're following along, pink and green, let's do this. All right, so we're going to take the shape that's a triangle made of A, B, C, and we're going to translate it, basically just left 12, and then I'm going to flip it over the y-axis. R stands for reflection. We also have rotation, which is little r. I use little r for rotation, big R for reflection, just because my old textbook used to do that. But, you do you. Live your life. I'm not going to tell you how to live your life. Let's do it. So I'm going to graph these like so. And I made it super long because I knew I had to go back 12, but it would be generally like here-ish. So let's graph the OG function. I really should have made that a little bit shorter on the top. It's fine. We're doing great. Okay. So now I'm going to take that function. I'm going to move everything to the left by 12. I don't care. Let's do pink. So instead of 3, 2, it'll be like negative, or it'll be negative 9, 2. But I'm just going to count left 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now again, I can do this again with B, or I can know that B is 1, 2, 3 over and 1 up from A. So I can go 1, 2, 3 over and 1 up from A. This is new A. This is new B. Did I forget the paper in there? No, I'm good. And then new C would be 2 down and 1 over from B. So this is, oh no, that's new C. So here's my first part of the triangle. That's where I just do the translation. Now I have to do the reflection over the x-axis. So I'm just going to flip everything. So this is 1 point up, so it'll be 1 point down. This here is 3 points up, so it'll be 3 points down. Or 4, 3. And then this is 2 points up, so it'll be 2 points down. See how I'm doing that? So this is new A. So we do A double prime. This one is new B, and this is the new C. We can do this all day long, but if you do more than 3, we usually start doing like a little number above, so it'll be like A power 4 kind of thing. Instead of doing like 18 little marks, we would just write a little 18 up there. But for now, it's just, this is the OG. This is after my first transformation, and this is after my second transformation. New ABC. So this is my triangle. A double prime, B double prime, C double prime, or A inch, B inch, C inch, if you're like my kid I'm tutoring right now. He calls them inches and it's cute, but it's wrong. Okay, so that kept the transformation, or kept the same shape, so these are congruent triangles. Excuse me, all 3 of them are. B kind of got a little taller, but I promise they're all congruent. All right, let's try one where we actually kind of go backwards and try to figure out the rule. All right, so we're going to describe the transformation or transformations that maps PQR to P, to the new PQR, basically. P prime, Q prime, R prime. So maps just makes one go to the next. So it's like when looking on Google Maps, it's me, and then it goes, whoop, go like this. And I'm like, all right, cool, Google Maps. Thanks for letting me know. South, rotate, south, east, etc., etc. So let's do an example of this. All right. So here's PQR, and there is the new PQR. Let's go through my options here. Is there a translation? Probably, because it was over here and now it's on this side, and it doesn't look like it got flipped over. Is there a reflection? Probably not. I still have PQR kind of in the same spots. It hasn't been like rotated or reflected at all. If it was upside down, like if Q was down here, probably. Is there a rotation? Probably not. A rotation would be if it's kind of like pointing up or pointing sideways. Is there a dilation? Absolutely. This is a lot bigger than it used to be, right? It got bigger. Now, here's your options. You can make it bigger and then move it, or you can move it and then make it bigger, okay? You have to be kind of careful about the second option, because if you move it so that way P is right here and then make it bigger with respect to the origin like we normally do, it'll move. It'll be moved over a little bit. So what I would recommend is I would make it the right size first, make it dilated first, and then slide it around. Or if it's flipped over, try dilating it first and then flipping it over to make it match. Now, the goal of mapping is to do it with as few steps as possible. I could add in 3 rotations, a reflection, and a couple more translations to make these shapes the same with my dilation, of course. But I want to do it in as few steps as possible. So we just want to like keep it low, you know, low maintenance. So we have a dilation here. What's our dilation? Let's check. Hold on, I did this wrong. I scared myself. I made this too short, and so it wasn't an even dilation. So to figure out the dilation, what I'm going to do is I'm going to identify what the length is of my sides, just to see if I can figure out what it is. So this side right here is too long. And then this side right here is 1, 2, 3, 4. See, I made it 3 on accident just now. Okay, and then this was 1 high, and this is 2 high. So that looks like it's been doubled. So what I need is, I need a dilation. I can either say with a scale factor of 2, or I could say what the XY is. That's the most common way for your book to write it. So we say from XY to 2X, 2Y. Okay, now I'm actually going to do that with my pencil or my pen or something, just to see where it ends up once I do the dilation. So here I take every point and I double the point, remember? So if this point is negative 4, 1, it'll be negative 8, 2. 4, 5, 6, 7, 8, 2. If this is the point negative 2, 1, it'll be the point negative 4, 2. And if this is the point negative 2, 2, it'll be negative 4, 4. Okay, so this is my dilation, right? That's my dilated triangle, and so I want to move this over now. So how far, what's the I forgot the word. Vertex is very wrong, but it sounds like that. Vector. What's the vector? Well, I can take any point and I'm just going to check to see how far it slid over. So it looks like this slid over 1, 2, 3, 4, 5, 6, 7, 8. Right? This was 8 and now it's here at 0. That was negative 4, now it's 4. So then I'm also going to do a translation where I go x plus 8, but the y doesn't change at all. It's like a flat translation. So that, my friends, is one way to map PQR to the new PQR, the pre-image to the image. There's a bunch of different ways, which is why answer keys are kind of hard for this, but it's okay. We'll get through it together. If you're like, does this work? I'll be like, yeah, probably. Let me check, and then I'll check for you. I got you. I got you. All right. Keep it real. That was the end. Good job. Clap for yourself. I'm so proud of you. All right. We're peacing out.